Right now, something extraordinary is unfolding right in front of us. Beyond the intense radiance of sun, an interstellar traveler known as 3Y Atlas has carried out an action that no comet ever recorded in astronomy's history has demonstrated. The glowing trail of dust and gas that always extends away from the sun did the opposite. For several continuous weeks, it pointed directly toward the sun, forming an orientation that contradicts everything we understand about solar radiation. And then, in one sudden moment, without any gradual shift, it reversed direction entirely. For researchers, this is not a minor curiosity or a harmless anomaly. It challenges the core rules that govern how objects behave in space. Solar wind and radiation pressure always push material outward, never inward. Yet 3Y Atlas acted as if these forces did not apply. Picture a candle's flame bending into the direction of a strong wind instead of away from it. That is the scale of the contradiction being observed. Observations from a Nordic optical telescope position on the Canary Islands, along with data from the James Webb Space Telescope, confirmed that this reversal was completely real. It was not an illusion, not an error in instrument calibration, and not a matter of viewing angle. A bright jet of material that had been extending toward the sun gradually weakened and disappeared. Then, within days, a new tail formed, stretching outward in the opposite direction. To witness, this was like watching gravity suddenly decide to pull upward instead of downward. When the object moved behind the sun in late October, slipping into a region no Earth-based telescope can see, a still and quiet concern settled over observers. Something inside 3Y Atlas has changed, and its timing couldn't be more intense. It is now at perihelion, the closest point to the sun, absorbing more than 30 gigawatts of solar energy every second, enough to vaporize any ordinary comet completely. Yet it continues to exist, silent, stabilized, without explanation. No one can say what form it will take when it becomes visible again in November. But one thing stands as undeniable. We are witnessing the beginning of an event that may alter what we believe about matter, motion, and perhaps even awareness in the cosmos. In deep space, objects like comets are expected to behave consistently. They're considered ancient frozen fragments, moving according to predictable forces. But 3Y Atlas refused that expectation. What astronomers documented in late September was not random disturbance. It was transformation, a precise and structured change in behavior, recorded from multiple observatories. At high altitude, the Nordic optical telescope captured the final images before the object vanished behind the sun. In those frames, the once steady and narrow jet pointing toward the sun began dimming. The slender beam of plasma that had defied solar force slowly dissolved into stillness. And then, almost as if responding to some internal signal, another tail erupted outward, aligning exactly as a typical comet's tail should. This was a complete reversal, a decisive shift. Simultaneously, the James Webb Space Telescope recorded infrared changes. It detected a decrease in temperature surrounding the core, followed by an even redistribution of brightness. The transition was too smooth to be random, too synchronized to be accidental. It resembled organization rather than collapse. Comets are often described as simple structures, dirty snowballs drifting passively. But 3Y Atlas behaves as though it contains coordinated elements responding with intention. The entire transformation happened in just 8 days, while the object was more than 200 million kilometers from the sun. No present scientific explanation accounts for such controlled adaptation. To the casual viewer, it may seem like a faint point of light shifting shape, but to experts in celestial dynamics, 3Y Atlas is rewriting the rules as it moves. It appears less like a natural fragment and more like an ancient mechanism demonstrating possibilities we do not yet understand. Now, with the object hidden behind the sun's light, all we can do is wait. The silence feels heavy, like the moment before something significant reveals its next form. As the object traveled behind the sun, hidden from every telescope on Earth, the scientific community found itself caught in a tension between curiosity and apprehension. Instruments continued receiving faint energetic signatures, but nothing visually concrete could be observed. This period of invisibility formed a kind of cosmic silence, an interval where the universe seemed to withhold answers deliberately. Researchers monitored solar activity closely because any fluctuation around the sun during this interval could reveal something about the traveler's internal structure. Yet the readings showed a strange steadiness, as if the object was absorbing solar radiation in a controlled manner rather than being overwhelmed by it. In typical circumstances, when comets approach such intense heat, sublimation becomes chaotic. Material bursts outward in unpredictable patterns. Tails stretch erratically, and fragments often break off. But in the last recorded frames before disappearance, 3Y Atlas displayed motion that suggested regulation, not collapse. The behavior resembled a system adapting rather than disintegrating. The very idea suggests that the object possesses structural properties far more complex than ice, dust, and rock. That implication carries weight, because it challenges the very categories through which we classify cosmic bodies. Researchers began reviewing archived data from its earlier trajectory, tracing the path it took long before it entered the inner solar system. They discovered that its voyage had been astonishingly smooth. Most comets that travel vast interstellar distances collide with particles, gas clouds, or gravitational disturbances that disrupt their path. 3Y Atlas, however, maintained a trajectory that can best be described as deliberate, crossing regions of space where random motion should have created noticeable deviations. That consistency alone has raised questions about whether its motion is influenced purely by gravity or some internal dynamic is guiding it. In late-night research observatories, teams compared movement logs, brightness patterns, and energy readings. The deeper they analyzed the data, the more the information resembled behavior rather than accident. Its brightness increased and decreased at intervals that matched environmental conditions, as though the object adjusted itself to maintain structural stability. When exposed to stronger solar streams, it dimmed its jet. When radiation weakened, its tail brightened. The response was measured and balanced. Speculation spread quietly at first, then gradually reached mainstream discussion among astrophysicists. Could this object contain layered internal compartments or an adaptive surface texture? If so, such attributes would set it apart from every natural comet ever observed. The idea that the object could adjust how it reflects or emits energy implies organization. And organization hints at design, or at least evolution guided by principles we do not yet understand. Meanwhile, astronomical societies across Europe, Asia, and the United States prepared for its reemergence. Observatories scheduled dedicated scanning blocks. Satellites adjusted sensor parameters, and deep space monitoring arrays recalibrated instruments to higher sensitivity. The return of the object would not be treated like a routine sighting. It would be observed with heightened awareness, almost like waiting for the reappearance of a lost signal that might carry meaning. There is a subtle psychological shift that takes place when scientists realize that the universe may be presenting information rather than simply existing. It creates an atmosphere where each observation feels like a message waiting to be understood. Many researchers reported that watching the data feed became a strangely emotional experience, a mixture of awe and caution. They were observing something that behaved unlike anything recorded in astronomical history. During this waiting period, a second question surfaced. If 3Y Atlas has already demonstrated behavior that defies expected physics, what might occur when it moves away from the blinding interference of the sun? The possibility emerged that its transformation is ongoing, and the phase behind the sun might be another stage in a larger process. Comets do not reorganize themselves in stages, yet the pattern of events so far resemble phases of transition rather than random fluctuation. The memory of the reversed tail remains central to this concern. That event was not a mistake, nor was it a minor incident. It represented a force interaction on a scale that shouldn't be possible. Solar wind pushes outward, but this object resisted that pressure for an extended period. That resistance points to some internal mechanism capable of generating counterforce or shielding. The existence of such an adaptive capability raises a possibility that the object is more than inert material drifting in space. As analysts replayed the footage again and again, a curious detail emerged. The moment of tail reversal did not appear chaotic. It did not flicker or break apart. It transitioned smoothly, as though a sequence had completed and another had begun. This level of coherence does not match the behavior of frozen debris. It aligns more closely with controlled dynamics. This realization traveled quickly through closed scientific channels. Meetings were held quietly, discussions conducted with caution because the implications are profound. If this object is acting with internal regulation, then it is not simply a comet. It might be a relic of something ancient, engineered in an era long before humanity existed. Or it may be a natural formation shaped by processes that we have not yet encountered, formed in environments far beyond our observational reach. Either possibility reshapes our understanding of the cosmos. The silence behind the sun becomes a threshold. On one side lies what we believe to be the structure of space. On the other lies what we are about to learn. The moment it emerges will not be just another astronomical observation. It will be a revelation of its current state, changed, unchanged, or evolved. As days pass, anticipation grows heavier. Telescopes remain aimed. Sensors remain active. The sky is being watched not only for light, but for meaning. We stand at the edge of discovery, and the universe is paused, allowing us a moment to recognize the significance of what is unfolding. The return of 3Y Atlas will not simply answer questions. It may redefine the questions themselves. As the calendar moved forward and the date of reappearance approached, the atmosphere in observatories shifted from quiet analysis to focused alertness. Every instrument capable of detecting faint illumination near the solar boundary was recalibrated. The object's last recorded state before disappearing had been stable, yet charged with potential. The scientific community understood the significance of the moment approaching. The instant 3Y Atlas emerged from the sun's blinding glare would reveal whether it had remained unchanged, fragmented, transformed, or evolved into something that surpasses previous understanding of interstellar bodies. Technicians monitored spectral data in near real time, watching for the faintest signature of reflected light. The region around the sun is filled with interference, making detection extremely difficult. But amid the noise, a subtle flicker began to appear in the data stream. It was weak at first, barely distinguishable from background radiation, yet its timing matched the object's expected trajectory. Slowly, steadily, that faint reflection strengthened. It was as though the object were resurfacing from a luminous ocean, carrying with it the secrets of what it had endured. Initial readings suggested that 3Y Atlas had not disintegrated despite the immense solar energy exposure. The brightness curves were smoother now, indicating a state that seemed unusually consistent. In ordinary comets, brightness fluctuates wildly as gas jets burst unpredictably. But here, the illumination followed a stable gradient, almost as if regulated by an internal equilibrium. The first telescope to capture a confirmed visual reappearance was a deep-field monitoring array positioned in Chile. The image, though blurred by solar scattering, showed something unexpected. The object's outline appeared sharper than before. The shape no longer resembled the irregular form typical of comets. It displayed a defined symmetry, a more cohesive silhouette. This was not the appearance of a fragmenting mass. It looked unified, organized, deliberate. The observation triggered immediate reanalysis. Theoretically, the object should have lost mass during perihelion. Instead, the shape suggested consolidation. If material had been lost, it had occurred in a way that strengthened rather than weakened the structure. This discovery reignited discussions that had begun quietly weeks earlier. The possibility that the object could possess adaptive responses now felt more grounded in data than speculation. Astronomers began studying the phase shift that occurred during the tail reversal event. A few weeks earlier, the tail had flipped direction, contradicting solar forces. Now, as the object emerged, new matter streamed outward in a configuration that followed the expected path, yet the emission pattern looked refined. The tail was narrower, more controlled, and its luminosity displayed a smooth distribution. It almost resembled propulsion rather than passive sublimation. Such characteristics carry implications that extend beyond cometary physics. If the object can regulate how and when material is released, it suggests structural layers that respond to environmental stimuli. Natural objects do not reorganize themselves according to changing conditions in this precise manner. This realization caused a noticeable shift in the language researchers used during analysis. Words like mechanism, regulation, and structural adaptation began appearing in technical summaries. Meanwhile, astrophysicists revisited earlier trajectory data. There had been speculation that the object's path, though seemingly gravitationally compliant, might have included subtle course corrections. These deviations were so slight that they could be easily dismissed as perturbations caused by solar radiation or gravitational tugs. However, when examined alongside the newly returned stability and refined shape, those minor course variations gained new attention. They no longer looked incidental. They resembled adjustments. Quietly, discussions shifted to the possibility that this object may have originated in an environment where such adaptive motion was necessary for survival. If it had traveled across star systems, navigating not just empty space but radiation belts, dust clouds, and electromagnetic fields, it would require some method of maintaining structural integrity over incomprehensible distances and timescales. The ability to shift, reorganize, and adapt would be essential. This line of thought leads to two profound interpretations. The first is that 3Y Atlas could be a natural object formed in a region of space where physical processes shape matter differently than in our local cosmic neighborhood. If that is the case, then the universe holds environments we have not yet conceptualized, places where matter organizes itself under conditions so extreme that new physical laws may be required to describe them. The second interpretation is more speculative, yet increasingly difficult to ignore. The object may be a remnant of ancient engineering, not active, not operating as a machine in the way we define machines, but something constructed or assembled with purpose in a time so distant that its original function may be unrecognizable, a relic that drifts across epochs, shaped by principles of design lost to our current understanding. Such a concept resonates with the deepest questions humanity has asked. Are we alone? Has the universe produced minds beyond ours? Could knowledge survive long after civilizations vanish? An object capable of self-preserving adaptation, drifting through interstellar space would be a powerful answer. Yet, caution tempers speculation. Science demands evidence, and the data is still emerging. The return of 3Y Atlas is only the beginning of the next stage of observation. Researchers must determine whether its behavior continues to align with adaptive regulation. They will examine how its brightness evolves, how its tail behaves during its departure from the solar region, and whether any anomalous emissions or signals accompany its presence. Even so, the emotional impact is undeniable. Across observatories worldwide, scientists paused when the object's first clear reappearance frame came into view. There was a sense that they were witnesses to something vast, an unfolding event connecting us to a scale of time and origin beyond anything familiar. In the days that followed, conversations shifted quietly from cautious curiosity to solemn recognition. The object had survived what should have destroyed it. It had not diminished. It had changed, refined, and reemerged with coherence and shape. The universe had shown something ancient and persistent, something that carried within it the memory of distances spanning beyond imagination. And as the world watched the data stream stabilize and the object move back into measurable space, one truth settled over the observers. We are no longer merely studying a comet. We are watching a story older than Earth return to visibility. As observation continued and more images were collected, the tone in scientific discussions shifted noticeably. What began as cautious monitoring had become a coordinated global effort to document every detail of 3Y Atlas's behavior. Research centers exchanged data streams in real time, and even facilities that normally competed for telescope allocation cooperated, as though the event demanded a shared awareness. The object moved gradually out of the sun's radiance, revealing itself with increasing clarity. Each new frame sharpened the contours and confirmed a form that appeared neither random nor deteriorated. The structure looked unified, cohesive, almost as though its components had settled into deliberate alignment during its time behind the sun. Spectral analysis revealed something even more startling. The composition signatures did not match typical cometary elements. Instead of irregular spikes associated with volatile sublimation, the readings showed balanced emission patterns. It was as though the materials were arranged in a consistent matrix, not scattered. The ratios of certain elements, particularly carbon-based and silicate-based compounds, appeared stabilized. Such equilibrium is not expected in a melting ice and dust formation exposed to extreme radiation. Stability in that environment suggests underlying reinforcement. This raised a question that previously seemed too speculative to voice openly. If the object contains a structured interior, what lies within that structure? Meanwhile, trajectory mapping showed that the object was no longer simply passing through the inner solar system. It had altered its drift subtly, adjusting its path by degrees that could not be explained by gravity alone. These course adjustments were small but deliberate. They nudged the trajectory into a smoother arc, aligning with a route that leads outward through a region of space with fewer asteroids and less particulate interference. This selection avoids collision risks that a natural object would not predict. A comet cannot choose its path. But 3Y Atlas appeared to do exactly that. This behavior did not go unnoticed. Conversations that had been theoretical now moved into formal research briefs. Specialists in celestial navigation began developing models that incorporated non-gravitational behavior. Engineers who studied spacecraft stability systems were consulted, not because anyone asserted the object was a vessel, but because its motion resembled controlled orientation rather than passive drift. At the same time, radio astronomy facilities around the world began monitoring for electromagnetic anomalies. No structured signal was detected, yet there were faint fluctuations that repeated at irregular intervals. These fluctuations were too soft to classify as transmission and too consistent to dismiss as background noise. The pattern resembled the kind of resonance produced when a stable structure interacts with solar wind in a balanced way. If the object has internal cavities or layered segments, those structures could produce harmonic reverberations. This possibility deepened the intrigue. Outside the scientific world, awareness spread into ordinary conversation. News outlets began reporting the event, though with limited technical clarity. Some portrayed it as a curiosity, some as a mystery, and others as a possible sign of something beyond human understanding. In online communities, speculation grew quickly. Discussions ranged from ancient starfaring civilizations to naturally evolved cosmic organisms. Though many ideas lacked grounding, the widespread attention revealed how deeply the event resonated in collective imagination. Humanity has always looked at the skies searching for meaning, and now something in the sky seemed to hold meaning that had not yet been unlocked. Inside observatories, however, the tone remained calm and focused. Scientists continued analyzing behavior, without allowing speculation to override evidence. Yet even within these controlled environments, a subtle shift in emotional atmosphere occurred. Researchers worked long hours without complaint, driven not by requirement but by an instinctive awareness that they were witnessing something that may be spoken about for centuries. It was not excitement in the usual sense. It was reverence. Across several nights of observation, the tail continued exhibiting controlled emission. The flow of material streamed outward in a narrow, consistent line instead of the chaotic plume expected. The rate of release fluctuated in harmony with solar wind pressure, not in opposition to it. That synchronization indicates adaptive modulation, whether formed naturally in unknown conditions or by design. Either interpretation suggests that the universe contains forms of matter arrangement far more sophisticated than previously documented. As the object moved farther from the sun, its visibility improved significantly. High-resolution images revealed faint surface banding, patterns that wrapped around the structure in curved arcs. These arcs resembled layering, like geological strata, but the curvature and spacing were unusually regular. Natural layering often appears irregular or fractured, yet these bands maintained smooth continuity. The structure looked less like frozen accumulation and more like something that had been shaped or evolved through prolonged function. The possibility that the object could be extremely ancient began to feel more plausible. If it originated beyond our galaxy or from a region where conditions differ dramatically, its current state might be the result of processes operating across epochs far longer than human civilization has existed. Age on such scales produces complexity that appears intentional even when it has no designer in the human sense. Gradually, the object began drifting toward the outer regions of the solar system, following the arc of its newly adjusted path. Observatories tracked every shift in brightness, every spectral variation, every subtle pulse of reflected radiation. The behavior remained consistent. The object did not degrade, fragment, or destabilize. It moved with a steadiness that seemed almost serene. As the days and nights passed, a profound understanding settled over many who observed the event. The universe is not silent. It carries traces of what has come before. Some of those traces may travel across the void long after the civilizations or environments that formed them have vanished. We may have encountered such a trace, ancient, resilient, and still changing. No definitive conclusion can yet be made. Evidence does not confirm design, nor does it prove natural evolution beyond known models. But what has become clear is that 3Y Atlas is not a simple remnant of ice and dust drifting passively through space. It is something more intricate, more enduring, more layered than any comet previously documented. As it continues its slow departure, telescopes follow it like observers watching a figure walk away across a horizon. The mystery remains, suspended in motion, moving steadily into the dark. The story does not end. It simply continues beyond our immediate sight. And the sky waits, as it always has, for the moment when understanding finally